Hi everyone, we are doing SA2 Revision Set 1 Booklet B. Let's look at the answers and explanation. Now let's look at question 31. Diagram below shows an animal cell. So recall this is the topic on cells. So you're supposed to identify the parts of the animal cells by filling in the boxes A, B, C with the words in the box below. Okay, so this is a fairly straightforward activity. So what is A? So A points to this. So this is basically my cytoplasm. So this is my cytoplasm. Okay. B points to this part in the middle here. So this part here is my nucleus. Something's wrong. Nucleus. C-L-E-U-S, nucleus. Okay, and part C is my cell membrane. So this is a very straightforward question. Let's look at question 32. So diagram shows a human system. So you're supposed to name the organs labeled X and Y. So again, this is quite straightforward. And so X will be your windpipe. And Y will be your lungs. So either lung or lungs. Okay. So does part Y become bigger or smaller when a person is blowing? When you blow into a balloon, what happens to Y, which is your lungs? So remember, when you're blowing, you are pushing air from your lungs into the balloon. That's what you're doing when you blow. So when you blow, the air in your lungs goes out and into the balloon. So will your lungs become bigger or smaller? Well, definitely it becomes smaller, and the reason is because we are breathing out air. Okay, so your answer can be phrased like that. Right, so part Y becomes smaller as he's breathing air out from his lungs. Right, so question 33, the diagram shows the fruits of two plants, coconut and my mango. So how is the coconut fruit dispersed, and what characteristics does this fruit have that helps it to in its dispersal? So this you should know by now. Coconut is definitely dispersed by water. And why is it being dispersed by water? Basically, it is able to float. And how is it able to float? It has fibrous husk. So the fibrous husk will help to trap air, so to enable it to float. Okay, so your answer should look something like that. Now fibrous is spelled like that. Okay, so fibrous husk, or if you can't remember the word fibrous, you can say that it has a husk that traps air. Okay, so long you mention that, you should get the marks. Now how about the mango fruit? How is it dispersed, and what characteristics of the fruit that helps it to be dispersed? So mango, it's yummy, juicy mango. We all love to eat mango. Sorry about that. So we love to eat mango. So it's because of this characteristics that it's being dispersed by us, animals. I mean, not just us, but all other animals. So it is dispersed by animals because it's juicy and sweet. Alright, let's move on. Right, question 34. Diagram below shows a concept map about cells. So you are supposed to complete the concept map by writing the correct parts of the cell in the empty ovals. Okay, so let's see. Plant cells have what? Animal cells do not have what? What is this thing that plant cells have but animal cells do not have? So let's recall. Nucleus both have, cell membrane both has. So what is it that a plant cell have that an animal cell does not have? Yes, it's either a cell wall or cytoplasm. Is it cytoplasm? No, not cytoplasm. What is it? Let me use another color. Yeah, it's sorry. Let's try this again. Chloroplast. Okay, so either a cell wall or chloroplast. That's what a plant cell have, but animal cells do not have. So let's see, where's the other over here? Okay, plant cells have, animal cells have. So both cells have this. Well, there are many. is either a nucleus, or you can talk about cell membrane or cytoplasm, so either one. Alright, so you just need one answer. Then plant cells have, animal cells do not have. So okay, so it's either, alright, so let's make things clearer. So I'll take away chloroplast here, and I'll write it below here. But if you switch it around, it doesn't matter. Okay, so here can either be cell wall or chloroplast, here can either be cell wall or chloroplast, but you cannot have both the same. Alright? Okay, question 35. Diagram below shows how water can exist in 3 states. Fill in the boxes with the correct processes. So let's highlight keywords here. Processes to complete the diagram. So I want the process. Okay, so let's see. From gas to liquid, what is the process? And from liquid back to gas. So let's just focus on this. Gas to liquid, liquid to gas. So gas to liquid, the process is condensation. Okay, alright, gas to liquid is condensation. Liquid, oh sorry, yeah, it's correct, condensation. Liquid to gas, the process is boiling. That's right. So when I want to change from liquid to gas, I have to boil it. When changing from gas back to liquid, it's condensation. So part B, when ice cream melts, there is a change in state. Name the change in state. Okay, so ice cream, what state is it before it melts? So ice cream, before it melts, it's actually at the solid state. Okay, ice cream, it's ice, is solid. So then when it melts, it becomes liquid. Okay, so from the solid to the liquid state. Alright, question 36. Now this is a very interesting question, and this is on seed dispersal, because once you see angsana, you roughly know that it's on seed dispersal. Okay, so diagram below shows an angsana fruit. Now if you have not seen an angsana fruit in real life, it looks something like this. Okay, Denise wanted to find out, so let's highlight some keywords. She wanted to find out if the wing-like structure helped the fruit travel further. That's my highlighter. Yeah, travel further. So the aim of the experiment is to find out if the wing-like structure helped the plant or helped the fruit travel further. Okay, so first she dropped the fruit from the 3rd floor of the school building to the ground floor. She then cut the wing-like structure of the fruit and repeated the experiment on the 4th floor of the school building. Okay, so basically from here she cut, and it becomes like this. Okay, where the wing-like structure is gone. No more wing-like structure. Okay, so then the question is asking, what should Denise measure? Okay, so the keyword here is what should she measure to find out the results of her investigation. So remember, what is she trying to investigate? She's trying to investigate if the wing-like structure helped the fruit travel further. So what do you think she should be measuring? Yeah, basically it's the distance, correct? When I drop to the point that it lands, how far away it is, because I want to see whether the wing-like structure helps it travel further. Okay, so this is how you should structure in your answer. So she should measure distance between the place where the fruit landed and the building. So that's what's that distance. Okay, now if you cannot imagine it, I'll just draw it up. So let's say this is the building where she dropped the angsana fruit. So basically when she dropped the angsana fruit, it will fly, right? And then where the angsana fruit land, so that this is, sorry, this will be the distance that she should be measuring. Distance from here to here. What is the distance? Okay, so that's what she should be measuring. All right. Now then, her teacher said that her investigation is not fair. What should Dennis have done to make it a fair investigation? Why is it not fair? Right, you should be able to see. Okay, here I'm going to highlight this. Initially, this was on the 3rd floor. After that, she went up to the 4th floor. So she actually changed one of the variable. Okay, because the only variable that should be changing is whether one has wing, one does not have wing. That should be the only variable that is changing, but she changed 2 variables. So that's why her investigation is not fair. Okay, so what should she have done? Alright, she should have dropped the fruit from the same height. Or if you say they should have dropped the fruit from the 3rd floor, both from the 3rd floor, both from the 4th floor, yeah, the idea is it must be from the same height. Okay, So why did Denise use the same fruit and not another angsana fruit like what I'm showing you? Why did she just use one fruit, cut off the wings to do the experiment, and not use two different fruits? Why did she do that? What do you think? Now again, it is to ensure fair test, because if I have different fruits, they may have different, the size of the seeds may be different, the mass may be different, so a lot of variables can change. But if I use the same fruit, the seed will always be the same. Okay, so again, the concept here is fair test. Alright, so how should you write your answer? So why did she do it? It's to ensure the fruit is of the same size or mass or weight. So that is what and why she used the same fruit. Okay? Right, let's look at question 37. So Damira wanted to find out how many sheets of paper a box could contain. So she found that she could fill it completely, so this box with 100 sheets of paper. So she just stacked, okay, when the sheets were placed flat in the box. Now she then took out all the paper and crushed them into balls. Okay, so crush into balls. Alright, and then she placed them back into the box. So could she put in less, more, or the same amount of paper inside the box when they were crushed into balls? Explain your answer. So logically, if you use your common sense and think about it, obviously she's going to have problems squeezing in all the paper into the box because it's crushed up. So definitely in your mind you will be thinking, yes, she would be able to put in less. But how do you explain it? Why is it that she's able to put in less and not the same or not even more? So what happens when I crush it? So when I crush it, basically what happens is air is being trapped inside. Okay, and because there's air inside and we know that air takes up space, so this test is testing you on the concept of whether you understand whether air takes up space. So because air takes up space, now that I've crushed the ball, I trapped air inside, I will need more space per paper as compared to if it's flat when there's no air. Okay, so basically that is how you should explain your answer. Alright, so less paper. Crumpled paper contained air spaces in between and so take up more space, or it requires more volume as compared to flat paper. Now part B. So if the mirror puts in plastic sheets of the same thickness as that of the paper and place them flat in the box as shown in the diagram, how many plastic sheets would she be able to put in the box? And you're supposed to explain. So essentially, you should know that it is 100 pieces, same number as the paper because it's the same thickness. Okay, so it's the same thickness, it doesn't matter whether it's a paper or plastic, it's just the materials are different. Same thickness means that it takes up the same amount of space, so the volume is the same. So if it's the same volume, means that if I can put in 100 sheets of paper, I can put in 100 sheets of plastic. Alright? Right, let's look at question 38. Now Sean thought of a way to prevent ice cubes from melting too quickly on a hot day. So he put 6 ice cubes in different numbers of similar plastic bags as shown in the setup below. Whatever, okay? So he recorded the time taken for the ice cubes to melt completely in the table shown below. Okay, so let's see. So the setup A has no bag, setup B 1 bag, setup C 2 bags, and setup D 3 bags. And then the time taken is recorded here. So the first question is, what is the aim? So I want to find out what's the aim. Why is he carrying out this experiment? Now remember, aim is always linked to variable. Okay, so I'm just going to write this down. Aim is always linked with variable. Alright, the aim of the experiment will determine the variable that changes. This is always the case, it's always true. Alright, so let's look at what variable has changed. Number of ice cubes is the same, so this is the same. The location, it's all the same. No, they didn't mention anything about the location. So what is it that is different? Yeah, the number of bags. This one has no bag, 1 bag, 2 bag, 3 bags. So the only variable that is changing is the number of bags. Okay, so what's the aim? So basically, he wants to prevent ice cream from melting too quickly, and he is using number of bags. So the aim of this experiment is to find out if the number of bags affect the what? What is he measuring? Okay, so you see at aim, it always has what is the variable that's changing and what is he measuring, because the measurements, the results will tell me or give me the conclusion for my aim. Alright, that is the one that I'm measuring. So what is he measuring? He's measuring the time taken for the ice cubes to melt completely, am I right? So basically his aim is to find out if the number of bags affect the amount, right? Affect the amount of time taken for the ice cubes to melt completely, the amount of time taken. Alright, so that's his aim. So explain why he did not put ice cubes in any plastic bag for setup A. Why did he leave it open? So setup A definitely will be what we call a control, where you don't have that variable, or you don't have the bag, so that you want to prove that the bag is the one. Because see, his aim is to find out if the number of bags affect the amount of time. So I have to have one that has no bag to show that if I have one bag, it affects and it helps to slow down the time taken for the ice cubes to melt completely. Okay? Alright, so his purpose is to show that any difference in the amount of time taken for the ice cube to melt completely is due to the bags. Alright, so part C, what's the minimum number of plastic bags he has to use if he wants to prevent the ice cube from melting for at least 30 minutes? So at least, not 30, 13 minutes, it is somewhere here. This is 12 minutes, so one bag is only 12 minutes, but I want 13 minutes. So it must be at least 2 bags or more. So minimum number will be 2. Okay? Right, question 39. Sing Tong had 3 bars XYZ, wanted to find out if any of the bars were magnets. The diagram below shows 3 setups of what happens when she places 2 bars near each other. Setup 1, shoop, repel. Setup 2, attract. Setup 3, attract. So what's the concept? Okay, so the question is asking which of the bars is or definitely a magnet. Explain your answer. So what's the concept here? How do we know that something is definitely a magnet? Yes, you should recall that something is definitely a magnet if they are able to repel. So repulsion or repelling is the only proof that 2 objects are magnets. Because if they can attract, one, it could be both are magnet, attraction, both could be magnets, or one is a magnet, one is a magnetic material. So you don't know which is which. So if repels, both are magnets. So which is the 2 magnets, X and Y? So explanation will be what I just mentioned. So it will look something like this. But X and Y are definitely magnets because they repel each other. The explanation is very simple. It's just because they repel each other. That's why they are both magnets. That's all you need to answer, explain. Okay? So which of the bars are definitely not a magnet? Explain your answer. So let's think about this. Now we've proven that X and Y are definitely magnets. So I'm actually left with Z. So Z can either be a magnet or a magnetic material. Okay, so here we're going to try to prove and see which is definitely, so I want a definitely not a magnet, so it must be a magnetic material. Okay, so let's see. Z, in both cases it attracts. So, is it magnetic material or magnets? So let's investigate further. Okay, let's look at X and Y. Okay. Now remember, if it repels, means it's definitely a magnet. So if we can prove that it doesn't repel, then it's definitely not a magnet. You get what I'm trying to say? Okay, if it doesn't repel, that means this bar will never repel a magnet. That means this bar must be a magnetic material. So no matter which pole I place it in, okay, I mean if both are magnet, if I place unlike poles together, they will attract. But if I turn it around, the like poles are together, they will repel, right? But if this is a magnetic material, no matter which place I put this bar in, it will both attract. So that's how you prove that this is definitely not a magnet, it's a magnetic material. So that's what we're trying to prove for Z. So let's see. Now, let's assume that this is N and this is S. It doesn't matter if you want A to be S and this will be N, the proof is still the same. So if this is S, this must be S as well because they are repelling. Okay, so I'm going to transfer this down to this diagram as well. So I'm assuming A is N, B is S. Okay, and then for Y, this C is S and D is N. Now, If Z is a magnet, okay, let's assume, let's think Z is a magnet. So, okay, I'm going to change color. So this will be, since the attract, this might be N, and then F will be S, the South Pole, okay? But if we transfer it in here, you look at bar Z, E will be N, F will be S. But this here, it attracts, correct? But assuming if Z is a magnet, by right, this shouldn't happen. Okay, so this proves that bar Z is not a magnet. Okay, so a lot of things. How are you going to write your answers? Check this out. Okay, so if bar Z is a magnet, D of bar Y, like what I mentioned, D of bar Y and E of bar Z should repel each other, but they did not. So that proves that Z is definitely not a magnet. Okay, I mean, another way of explaining is, if Z is a magnet, this shouldn't happen. In both setups, it attracts. Okay, that means in one setup, it should repel. Okay. All right. Let's look at question 40. Benissa and Salama grouped some materials according to their properties. After writing the properties in the classification table, a part of the worksheet was dirtied by ink. Whoops. So this ink was spilled there. Oh no. And some information could not be seen. So you're supposed to fill in the flow chart below with suitable words based on the table above. And write objects A, B, C, or D in each of the circles. So each circle, you must write the letters A, B, C, or D. And write a question in each of the boxes labeled I and I. Okay, so part 1, you have to write in a question. Part 2, you have to write in a question. Okay, because it's a question, then there's an answer yes or no. Okay, so let's see. Let's start with objects. Is it a metal? Yes. Then this, and then yes and no. So let's see. I've got A, B, C, D. So let's look at A first. A is a metal and it's magnetic. So let's see. Objects is a metal? Yes. So A should belong to this group. It's either here or here. So what should this question be? What is the next property of A? Magnetic. Now if we look at B, B is also a metal and it's non-magnetic. So this should give you an inkling of to what kind of question this will be. So for part 1, the question is it magnetic? So yes, if it's a magnetic, then my answer would be A. A will be here. Is it magnetic? No, it will be B. Okay, so look here again. A is metal and magnetic. B is metal and non-magnetic. So objects, metal yes, magnetic yes, A. Metal yes, magnetic no, B. Okay, so I think you're getting the hang of it. Part 2, let's see. I'm left with C and D. So D is non-metal. So okay, non-metal is here. Is it metal? No. So non-metal is here. So C and D will be here, right? Because they're both non-metals. But then what is the other property? What is the other question I can ask? So here I can't see it. It's spilled by the ink. But here I can see allows all light to pass through. That's something I can see. Allows all light to pass through. So ideally or most likely D will be does not allow light to pass through. So my question 2 will be, does it allow all light to pass through? So, or another question you ask, is it transparent? Yeah, because when it allows all light to pass through means it's transparent, right? Okay, so anyway, so does it allow all light to pass through? If it's yes, allows all light to pass through, then it will be C, and most likely D will be here. Okay, so that's how you fill up this table, this flowchart. Alright, question 41. A few primary 5 students, maybe some of you might have done this experiment, putting some hot water into 2 similar tanks. Alright, place 2 containers of the same material but different sizes. So here is important, different sizes. Here, as you can see in the diagram, let me shift it down a bit. Okay, now each of the tanks then covered with a metal walk. Alright. After a few hours, the pupils found that some water was collected in container X and Y. Describe how this happens. So what do you think is happening? Why is there water here? Basically, this concept is on condensation. So remember, when it comes to condensation, there are about 4 things you need to talk about. Okay, so remember the 4 things. Hot or the warm water vapor will touch the cooler surface, loses heat, and condenses or changes to water droplets. Okay, so you must have these 4 points there. So, how you get your answer? Before that, how do you get the hot water vapor? It's from the hot water, and the hot water evaporates and changes to water vapor. Okay, so you got to explain the whole entire process of evaporation and then condensation. Okay? So the hot water in the tank evaporated to form water vapor, so that's half mark. Water vapor touches the cooler surface of the wok, another half mark. Loses heat, another half mark, and changes to water droplets. I mean, if you want to continue to say that, then it drips into the cup. Yeah, that's fine. But the key here is evaporation, touches cooler surface, loses heat, and then condensation. Okay, so always remember that. Now, in which container would there be less amount of water collected? Explain. So, which do you think will have lesser amount of water collected at the end? So, all other variables being kept the same. The only variable that is different is the container. So, which do you think? Bigger container, I'll collect more water, right? That's what you might be thinking. But no, if you think about it, this container is bigger. You see the amount, the water level, both are the same. And the question didn't say that he put the same amount of hot water into the tank. He just put some hot water. So if you look at the water level, both are roughly about the same. If I have a bigger container, it means I'm taking up more space. If I have more space, I've got lesser amount of water, because water takes up space. So I got lesser water in my container or in my tank. But if I have a smaller container, I have more space for my water in my tank. So which one will have more water at the end? The one with the smaller cup, because it has more water to be evaporated, more water to condense and drip in. This one has less water. Okay, so this is how you explain your answer. So container X as because there's less water in the glass tank. That's as simple as it is. Now some of you may also notice that, oh, the exposed surface area for this is more, exposed surface area for this is lesser. So because of that, the rate of evaporation will be slower compared for this as compared to this one. The water will evaporate faster, and therefore within the same amount of time, this will collect more water. So that's true as well. Okay, so you can explain it in both ways. Okay, question 42. Audrey boiled some pure water and let it cool down afterwards. The graph below shows a change in temperature of water over a period of time. So here are some key information. The water took 10 minutes to reach boiling point. 10 minutes to reach boiling point. You're supposed to complete the graph. Okay, complete the graph by writing the temperature of boiling water in one of the 3 boxes besides the y-axis. This is the y-axis. You're supposed to write the boiling temperature of boiling water in one of the 3 boxes, not all 3. So, okay, let's see. The water took 10 minutes to boil. So let's look at the graph. 0 minute, 5, 10 minutes. So it took 10 minutes to boil. So at this point here, what is the temperature? Yeah, the temperature is definitely 100 degrees Celsius, because boiling point of pure water is 100 degrees Celsius. So you just put 100. Units not necessary because the units is already reflected here. Okay, so this is 100. Okay, part A done. Let's look at part B. Water was left to boil for another 5 minutes before the stove was turned off. Draw. So here you need to draw now and extend the line on the graph. So you're supposed to continue on from the graph here to show the change in temperature of water until the 30th minute. Okay, so let's see. So some keywords, some key information here. Boil for another 5 minutes. So concept here, when water is boiling, does the temperature keep going up? No, you should know during the boiling process, temperature remains constant at 100 degrees. It doesn't go up. So boil for another 5 minutes, right? So this is how your graph should look like. For another 5 minutes, each interval is 5, so you should use a ruler. I don't have a ruler here. So boil for another 5 minutes. After 5 minutes, what happens? Stove was turned off. So when my stove is turned off, what is going to happen to my temperature? my temperature would start to drop. Okay. Now, when will it drop? As in, where does it all the way down? All right. So at the 30th minute, where should the temperature be? Can it drop all the way? No. All right. You should know that when the water cools, heat flows from a hotter to a cooler region until both reaches the same temperature. So if my cup or if my whatever this water is in the room, it cannot go below room temperature. It must decrease and slowly decrease all the way until it reaches room temperature, and it will stay there at room temperature. Okay, so there are a few ways of drawing the graph. I'm just going to show you one way. Now another thing to note is boiling takes about 10 minutes. Cooling down cannot be so fast because Audrey just left it there. It's not that she put it in the freezer or fridge. So if your graph is when it reaches down to room temperature is less than 10 minutes, then that's wrong. Okay, so roughly it should look something like this. So from here, okay, let me change another color. From here, you can go down. Oops. Oh no. Okay, hang on, Alright, it can go down all the way and to it must be at room temperature. Okay, now another way of writing it, I'm going to use red, is you can let it drop to at about 25th minute it reaches room temperature, and what you must ensure that after that it's a horizontal line. Okay, because remember the temperature cannot go beyond, cannot drop down more than the room temperature. Okay? Right, let's look at question 43. So Jaden set up an electric circuit as shown below. Which two switches should Jaden close so that only 2 bulbs will light up? So I want to close 2 switches so that only 2 bulbs will light up. So let's see. If I close which is the one that I must close? Yeah, S4. Because if S4 is open, there is no way that it will be a closed circuit. No paths. Okay? So definitely S4 must be the first one that I must close. Okay? So S4, switch 4 is definitely one that I must close. So then let's see which is the other one that I must close. Okay, so you can either close S3. So if I close S3, S4, then this is the path it will take. Okay, let me highlight this. This is one path, S3, S4. Okay, is there another path? Yeah, if I close S2, let me use another color. S2 will go down. Now if S1 is open, the electric current will flow this down this way and go up here and up S4 and back again. Okay, so the answers are either you close S3, S4 or you close S4, S2. So there are 2 possible answers. S2, S3 or S4 and S2. Okay, so either one of them will do. Part B, when all the switches were closed, one of the bulbs fused and none of the other bulbs lit up. Which bulb is the one that fused? So all switches have closed. One fused, none of them light up. Okay, so it is quite obvious that B4 is the one, because B4 is the one next to the battery. So if there is an open circuit here, there's no way that there will be a closed circuit anywhere else. Alright, so which is the bulb that fused? That would be B4. Okay. Now which bulb would not light up if S2 was replaced by a wooden stick and all other switches were closed? So if S2, so let me erase all this. If S2 was replaced by a wooden stick. Now wooden stick means it's an electrical insulator, so that means there's an open circuit here. So question is, which bulbs would not light up? So my electricity can flow down here like that, no problem, and B3, B4 will still light up, but here on, electricity cannot flow. There's no closed circuit here. So which are the bulbs that will not light up? B1, B2. Okay. So B1 and B2. Okay. Okay, last question. Question 44. Study diagram A. So study it. Okay. Now you're supposed to draw, okay, another circuit to show that the two bulbs are brighter than the bulbs in diagram A. So you're supposed to use the same number of bulbs, same number of batteries, and switch. Okay, so you cannot change the batteries or bulbs. So basically what you're trying to do is to thinking of it in terms of arrangement. Okay, because brighter, so arrangement affects the brightness. So recall, what have we learned about arrangement of the bulbs? So bulbs in series is not as bright as compared to bulbs in parallel. Okay, because series, you can think of it as they are sharing the amount of electrical energy, but when they're in parallel, they have equal amount of electrical energy. Okay, so that's why they'll be brighter as compared to if I'm in series, because I'm sharing. Okay, so how do you draw it? Well, it looks something like this. Pardon the drawing. So what you need, make sure you have two batteries, because I want to keep it the same number of batteries. Alright, I need to have a switch. So I'm just going to draw this down. I need to have a switch here. Okay, so then I have one bulb here. Whoa, what's wrong? Okay, so a switch again. One bulb. Alright, connect it back. Because it's parallel, I have one more in between here. So this is my parallel circuit, and so this bulb, the two bulbs will be brighter as compared to diagram A. So what would happen to the other bulb if one of the bulbs from the circuit in diagram B was removed? Okay, so again, this is one of the advantages of a parallel circuit. When one is removed, when you have one removed, the other bulb will still light up. So that is the advantage. For series circuits, it does not happen. When one fuses, or one blows, or one is removed, all other bulbs will not light up. Okay, so what will happen? The other bulb will still light up. That's it. The other bulb will still light up. Straightforward. Okay, right. Enjoy yourselves.